Unit 4 in the AutoCAD Civil 3D 2010 education curriculum addresses environment design. And Lesson 1 focuses on sustainable design. The exercises are as follows. Exercise 1, you can visualize flow patterns. Exercise 2, you visualize roadway drainage. And in Exercise 3, you design a rain garden. When considering sustainable design, it's important to understand the hydrologic cycle, or the cycle of evaporation and precipitation. You also want to understand surface runoff calculations, or the volume of stormwater discharge from a surface, and also understanding land cover. Paved surfaces are impermeable surfaces, whereas soils are permeable. And typically, when you're designing a site, you want to ensure that your pre-development runoff into the rivers and the associated streams and drainage networks matches the post-development runoff. There are a number of sustainable design strategies. Footprinting means to minimize soil and vegetation clearing and incorporating those natural elements into your designs. You want to maximize the amount of impervious areas in the development, so green spaces to allow water to infiltrate into the ground. You want to maximize overland flow, essentially minimize the use of channels to manage flow and discharge from a site. Ensure that your site grading plans either preserve or lengthen the pre-development runoff paths. And once again, this is controlling the overall discharge of stormwater from your site. You want to try to lengthen and flatten your site slopes and use open swale systems. And post-development runoff typically should equal your pre-development runoff. And finally, detention ponds for stormwater, for not only the quantity of water but also the quality of water. For example, in a hot area, you may store water on building roofs, and it might get hot from running off of paved surfaces and parking lots, and to discharge hot water into a stream could be harmful to the natural habitat of that stream. So sometimes detention ponds are used to actually cool water before it's allowed to discharge into the existing natural water network at a controlled rate. In Exercise 1, you use the surface analysis to show the direction of flow. And this is simply using a style to be able to show how data is how water will run off of a surface. So if we just go over to the Settings tab, the Tools space, and under Surface, there's Surface Styles, and there are lots of different ways you can use styles, but this particular style here will color contours based on the elevation that contour is at. So you create a surface from point group data, so we could go ahead and do that. On a prospector, we could create a new surface, and this just call this EG for existing ground, and then the style that will apply is contours colored by elevation for now. And then what data will we use for that surface? We'll use point group data, and then existing terrain spot elevations, so we could then create that surface from those points in that point group. And then you could assign a style to display that particular surface. So if we were to zoom to that surface now, and just make sure that we actually built it. There it is. There's our surface in the drawing area. And then you can use a surface analysis to apply style to contour based on elevation ranges. So if we pick that surface object and went to Surface Properties, we have contours colored by elevation, And then you can do an analysis, and a number of different ways. We can do contours, use 6 different ranges here, and then add, and you can see how the contours will be assigned different colors based on the elevation range. And you can also do things by such as adding these directional arrows on here to shade the areas, and you can also apply, as indicated in the prior diagram, arrows to show the direction of flow. So you could use slope arrows here to show the direction of flow. In exercise 2, you run a surface analysis and apply a style to show slope direction arrows to visualize roadway drainage. And then in the final exercise, you use feature lines to design grading and create a surface for a rain garden. And that concludes the overview of the first lesson on sustainable design in the environmental unit